So good morning, everybody. Thanks. There is a lot of people attending in the room. Not put you too much pressure, Elie, but it shows that of the interest of the people to listen to you. So you have about half an hour to present your PhD comprehensive activities you have been doing so far in public. Then we will allow for a few questions in the room and in the chat. And this will be followed by a closed session where you have only the dissertation advisory committee members attending the meeting with you. And this will be done. So the public part, let's say, is for just the first half an hour plus questions. It's clear for you, Elie?
Yeah.
Okay, clear. So don't forget to keep close to the microphone so that the people online, they can hear you and you can go ahead.
Okay, thank you so much, Professor Jean. Thanks to everyone for attending my comprehensive examination. So I am Elie. I'm doing my PhD here under the supervision of Professor Jean Siar and Professor Nikos Michalopoulos here at the Cyprus Institute. And it's within the Climate and Atmosphere Research Center in collaboration with the Department of Labor Inspection. And my PhD is in the framework of two projects, the International Atomic Energy Agency and the AccuServe. The title of my PhD is about spatial and temporal variability of atmospheric PM pollutions in Cyprus. So this is the outline of my presentation. I will start with a brief introduction on atmospheric aerosol. And next, I will present the state of the art, what we know about pollution in Cyprus and in the Eastern Mediterranean and Middle East. I will present next my research objectives and scientific questions, and then the methodology that we are proposing to address those research questions. I will present some preliminary results, and then I will finish with some conclusions and timeline. Atmospheric aerosols are emitted either from anthropogenic activities or from natural sources. So they are classified as primary, those that are emitted directly into the atmosphere, while secondary aerosols are formed in the atmosphere through gas to particle conversion. Atmospheric aerosols are distinguished by some properties. One of those properties is the size distribution. For this, we distinguish fine particles. Basically, all of those particles that have a diameter smaller than 2.5 micrometers, and the coarse particles are those ones that are having a diameter larger than 2.5. And the fine particle here, what I would like to say is that they are majority in number, while coarse particles dominate the aerosol mass. They can also be distinguished based on the chemical composition. So here the main PM constituents can be grouped in 5 categories. So we are having secondary inorganic, carbonaceous species, crustal matter, sea salt, and trace elements. Why do we care about atmospheric aerosols? One reason why we are interested in studying atmospheric aerosols is the impact they have on our health, which range from skin irritation to cardiovascular diseases and lung cancer. For this reason, fine particles are known as one of the causes of mortality worldwide, with around 4.2 million premature deaths caused by fine particles worldwide, and around 620 in Cyprus. And you can understand that this is going to have an impact on the economy through the health care cost and the reduced labor productivity. And for this, it's estimated by the World Bank that the economic cost of fine particle is around $3.6 trillion per year globally, and around $857 million per year in Cyprus. This is a huge amount because it's equivalent to 3.3% of the country's GDP. So what I would like to say here is that the impact of aerosol on health depend on many factors, including the size, the concentration, the exposure time, and of course the chemical composition. Another reason why we study atmospheric aerosol is the impact they have on climate. So atmospheric aerosols are known to have a negative radiative forcing, which means that they cool the atmosphere through aerosol radiation interaction and aerosol cloud interaction. So what I would like to highlight is that this radiative forcing of aerosol is strongly dependent on the chemical composition. What do I mean by this? While some components like nitrate, sulfate, sea salt are cooling the atmosphere, other constituents are warming the atmosphere. Here I will give an example of black carbon. So moving on to the state of the art, what do we know so far about pollution in our area, and what are the main gaps? So we know that the Eastern Mediterranean and Middle East is a hotspot for air pollution. So I will give some examples here to prove why we say that it's a hotspot for air pollution, starting with the dust. So here what we see is an image from satellite observation. This is showing a very high dust levels based on aerosol optical depth over North Africa and Middle East. It's not only the natural sources that are concerned here in this region, we also have anthropogenic sources affecting this area. The image that you see is from Tropomi satellite, and we can identify the main hotspot for NO2, which is emitted from fossil fuel, in the main urban agglomeration of the Eastern Mediterranean and Middle East. So another example is very high level of tropospheric ozone, which is a secondary pollutant. And this is because this area is characterized by strong photochemistry. So what are the drivers for this? So what we know is that this area is receiving pollution from 3 continents. So we have pollution and dust from North Africa, pollution and dust from Middle East, and we have pollution from Europe. So we also know that the EME region is characterized by very high temperatures. And according to this recent study, this area is warming 2 times faster than the global average. Another driver for this high pollution is the population growth. You can see how fast the population in the EME region is growing, and this also is having an impact on the air quality. Last but not least, we know that Middle East has a large number of oil reserves. Again, this is promoting air pollution in the area. So now moving on to Cyprus, what do we know about PM pollution in Cyprus? So the first information we have is that Cyprus is characterized by very high dust level. So the graph you see on the left is showing the comparison of dust in the Mediterranean basin. Here we are talking about the EU countries only. So you can see that the highest dust level is observed in Cyprus among all the EU countries. So it's not all about the level that is high, but also the frequency of those dust events. So we have from this study, 3 sites were compared from Israel, from Cyprus, and from Greece. So we see that the highest frequency of dust event is observed in Cyprus. Another important fact is that Cyprus is the only EU country that is affected by Middle East dust events. So you can see from the right-hand graph that even Phoenicias, which is not very far from Cyprus, is not affected by such events. Here, I'm giving an image showing intense dust event from, this was taken in Limassol in 2015. You can see how the visibility was affected. And so what we see from this is that the level of PM10 exceeded the EU limit by 2 orders of magnitude. So now moving on to the PM sources in Cyprus, what I would like to highlight here is that even though a few studies were conducted so far, still the information on PM pollution is still critically missing. So here I have selected 2 studies which are the most comprehensive ones, and this is what I'm going to discuss now. The first one by Achilleos et al. 2016 on chemical composition and sources. The main conclusion from this study is that the regional sulfur is the major fine PM source in Cyprus. However, a few aspects were missing in this study. First of all, the temporal resolution was not good enough because samples were collected once every 6 days. And you can understand that from this, we can miss a very important pollution or dust events. Another aspect is that a few chemical species were not measured, such as ammonium and nitrate. And also little information was provided on carbonaceous aerosols. So another study by Pikridas et al. 2018 about trends. From this study, we see that there is a decreasing trend for both PM2.5 and PM10. We also see that local sources of PM10 account for 36 to 44%. However, given that they didn't have chemical composition data, no firm conclusion were made on what could be the causes of these observed trends. So, given the observed gaps, 4 research objectives were proposed. The first research objective aims to provide a comprehensive fine PM source apportionment in Nicosia for 1 year. The next one is about exploring the distribution of fine PM composition and sources over Cyprus, again for 1 year. The third one is aiming to identify the main regional point sources driving PM pollution over Cyprus, also for 1 year. And the last one is about interpreting possible long-term trends in PM sources in Cyprus for a larger time scale of more than 10 years. So next I will present the scientific questions associated with my research objectives. The first question is about the main drivers which are responsible for this pollution. And the strategy here is to perform continuous PM sampling for high quality source apportionment analysis. The second question, which is about the additional information we can gain on carbonaceous aerosols. So we address this by comparing offline with online PMF source apportionment. The next question, which is about the common features and main differences in terms of fine PM pollution for Limassol and Nicosia, which are the main cities of Cyprus. For this, we collected samples at the same time in Nicosia and Limassol. And the next question is about the local and regional contribution to PM pollution in Cypriot cities. So for this, we collected samples at urban and regional background sites, and we applied the so-called Lencho approach. I will explain this later. And the fifth question is about the main regional pollution hotspot contributing to PM pollution in Cypriot cities. And we will address this by performing source region analysis with the flex part and potential source contribution function. The last question, it's about whether we observe any trends in local and regional contribution to PM pollution over the last 10 years. So here we conducted long-term observation for statistical trends analysis. So for the methodology, I will present first the study area. So this study is conducted in Cyprus. Cyprus is a country which is centrally located in the Eastern Mediterranean and Middle East, and it's surrounded by non-EU countries. And as a matter of fact, this country is likely to be affected by non-EU regulated pollutants. Also, since I will be comparing the major cities of Cyprus, here I will give some characteristics of each of them. We know that Limassol is a coastal city. It's hosting the busiest commercial port of the island, while Nicosia is located inland and it's lacking the major industries, but it has a larger population. So regarding the monitoring sites and sampling setup, so here we considered 5 monitoring sites, 1 urban traffic, which is Nictra in Nicosia, and 3 urban background, Nikres in Nicosia, Rimres in Limassol, CAO-CYI in Nicosia, and 1 regional background at Ayamarina Xiriatu, which we call IMX. So this is the sampling setup for different research objectives. We conducted the chemical analysis, most of them at our chemistry lab, and a wide range of chemical species were quantified, which were later used for source apportionment. So now moving on to the source apportionment, we use positive matrix factorization, PMF. What is source apportionment here? It's about deriving information on pollution sources and the amount they emit. How does it work? So we are taking ambient measurements. So here I'm collecting sample. We are performing chemical analysis. We get all of these informations, and we use them in our source apportionment in the PMF model. And at the end, this is what we get. We get 2 information. We get a source-specific chemical fingerprint and contribution of each source. So for estimating the local and regional contribution, we use the Lencho approach. This methodology states that the concentration that we are measuring in the city is made of 2 components. So the first component is what is emitted within the city, and the other component is the regional component, which is mostly long-range transport. And for this, we are using data from the regional background side, which is Ayamarina. So for regional hotspot identification, one of the tools that we are using is a potential source contribution function. And how does it work? So we need 2 information. We need the ambient measurements, and we need the back trajectories. So we use all of these 2 information as input in this software. And at the end, we get a potential source region, which look like this. So you can see some hotspots for in different areas. I will discuss this later. And another tool that was used for hotspot identification was FlexPath, which is a Lagrangian particle dispersion model. So this is the setup for the model. And after the model run, we get the so-called retroplumes, which look like this. Once we have those retroplumes, we proceed with the air masses classification, which is basically the grouping of our retroplumes based on the air masses sectors. So now moving on to the preliminary results, I will remind you that my first objective is to provide a comprehensive fine PM source apportionment in Nicosia. So for source apportionment, again, I will remind you that we were using PMF, positive matrix factorization. And what I'm showing here is the chemical, what I said, the chemical fingerprint for different sources. And the main message from this analysis is that the long-range transport source is the main one in Nicosia, especially during summer due to strong photochemistry. Another point that I would like to highlight here is that during winter, biomass burning is the dominant source due to domestic heating. It's even more important than traffic that we used to blame. And for organic aerosol properties, we are comparing offline with the online PMF. First, we compare the long-range transport with the more oxidized organic aerosol, and we can see that from this comparison, there is a good agreement between the two methods. Next, we are comparing our offline biomass burning with the BBOA from online PMF. And from this comparison, we can say that our offline biomass burning is likely to contain primary and secondary organic aerosols. And finally, we are comparing the offline traffic with HOA1 plus HOA2. HOA1 is related to traffic, while HOA2 is a mixture of conversion sources. And this comparison suggests inclusion of other conversion sources in our offline traffic factor. So regarding the second objective, which is about exploring the spatial distribution of fine PM composition and sources over Cyprus, here I am showing the local and regional contribution to the PM mass. This is for annual average. The key message here is that only 40% of PM mass is produced locally in Cyprus. However, if we analyze season by season, the picture is going to change completely. So what we see here is that during winter, instead of having the regional sources a dominant one, we have local sources, which are the most important. And this is due to domestic heating. So by comparing Nicosia and Limassol, again, here we can have some information on the sources that could be affecting the two cities. So here we observe a weak winter to summer contrast. And this is suggesting that the two cities may be affected by different local sources or different atmospheric processes. Now, moving on to the PM sources, again, the local and the regional contribution. So I am presenting separately the two fractions, the local fraction, the regional fraction, and the local fraction. So for the regional fraction, we can see that the sulfate-rich source is a dominant one, and this suggests high influence of fossil fuel conversion. Regarding the local fraction, what we see here is that most of it is coming from biomass burning and traffic. Another aspect here to highlight is that dust is very significant in the fine mode. So this is not expected because most dust is expected in the coarse mode. There are larger particles. So moving on to the third research objective, which is about identifying the main regional point sources driving PM pollution over Cyprus. What we see here, so first, Middle East is a hotspot for everything. It's a hotspot for all the species. And also, this is something which is expected. North Africa is an additional source for dust. And finally, we can also see that Turkey, and Eastern Europe are additional sources for sulfur-containing species. So moving on to the last research objective about interpreting possible long-term trends in PM sources in Cyprus. From this graph, we can see here I have two information. One is that Middle East is associated with the most elevated level for most species. Another information is that there is an increasing trend. So now I will move to the conclusions. What we have seen so far, the long-range transport source is the dominant one in Nicosia, especially during summer. Biomass burning is the leading source during winter due to domestic heating. And we also saw that around 40% of PM mass is emitted locally, only 40% in Cyprus. And this local fraction is originating from biomass burning and traffic emission mostly. We also saw that Middle East, Eastern Europe, and Turkey sectors are the main pollution hotspot affecting Cyprus. Finally, we saw that the Middle East sector is associated with the most elevated PM level with the increasing trend. So now I will move to the timeline of my PhD. So here, what I'm highlighting with green is what I have already completed. What I'm working on now is in yellow. What I haven't started yet is in red. We are here today. So until the end of this month, I will be working on the second paper, which is about quantifying the local and regional contribution to PM pollution in Cyprus. And until the end of August, I will be working on the third paper about long-term trends analysis. From July to November, I will be writing my thesis, which will be defended in December. So this is what I have achieved so far during my PhD. I have contributed to 3 publications, and we have 2 more in preparation. Also, I have attended several conferences here in Cyprus and abroad, and for some of them I presented. So with this, I would like to thank you for your attention.
Thank you very much, Elie. 27 minutes. So very good timing. I would like to invite people in the room to ask questions if they have. If possible, please use the microphone. So there is a microphone here. So that will be allowing people online to listen your questions. You have, yes, Franco.
Yes, Elie, sorry, maybe I didn't see your slides very thoroughly, but my question is, do you see in the dust, do you see a local component of dust generated in Cyprus, or do you only see long-range transported dust?
Actually, yes. Actually, the it's far. Here. So yeah, it's very important. It's the local fraction is more than 20%. It's around a quarter of PM fine PM mass.
This is Nicosia.
For all the cities, so we have Nicosia and Limassol. In Limassol, it's even more important.
You have even more in Limassol.
30%, yes.
Okay.
Yeah. So in Limassol, it could be the cement plant, which may be affecting the sampling site.
Any idea what is the local source of dust in around Nicosia?
Here it's So we have also from traffic, because the PMF tool is not perfect one. So we have some traffic emission, the non-exhaust in our dust fraction, in our dust factor. So traffic can be one of those sources.
Okay.
Yeah.
Thanks.
Thank you, Elie, for the presentation. And I'm more, let's say, on the applied side of what you're researching. So I'm working in solar energy. So we are also affected by these events. I wanted to ask you something that maybe is general for what you're doing as a department is how can you deal with the fact that third of the island is not reachable. So I mean the occupied part. How can you evaluate or have some weak or indirect indicators to tell you what is the pollution about from this part of the north? So that is one aspect. And also I wanted to ask you on the long run. So these particles, I guess, at some point they will deposit on the island. Can we expect a change into the landscape of Cyprus or the, let's say, desertification or something on the long run?
So for the first question, which is about the two sides of the island. So so one of the methods that we can use to quantify how important is the emission from the north or the south is through the space observation. And there are several, I think I know one study by Mihalis Verekousis, which is showing high contribution from the power plant from the north compared to the south. So this is one way to evaluate. And so we can also most probably use the air masses origin or the wind, check the wind direction. For example, when the wind is coming from the north, it's not an ideal method, but maybe it can give us some indication when we just take the local fraction. And remind me the second question.
Okay, yeah, also regarding this remark is that when you have winds coming from the north, even though you cannot know if it comes from, let's say, Anatolia or if it's coming from let's say Kyrenia, for instance. So I guess it's very difficult, yes, to discriminate unless you have directly measurements in the north. But I guess it's not possible. Regarding the other question, maybe you don't know. It's on the long run. Can we expect desertification of Cyprus or something with all these
because
particles?
of the dust we receive?
Yes.
I don't think so.
Okay.
Yeah.
Okay. Thank you.
Yeah.
Vijay, you have a question. Go ahead.
Yeah, Elie, excellent presentation. I have a very quick question. Mediterranean Sea is one of the most saltiest sea. We have a lot of salinity.
Mm-hmm.
I'm just surprised to see that you have very less fraction of sea salt aerosols. Why do you think so?
We are talking about fine aerosols. So if we were taking PM10, it will be higher.
PM2.5 or PM? Okay, not PM10.
No, it's not PM10. We are talking about small particles.
Okay, fine. Yeah.
And thank you. It was a very nice presentation, and you covered a lot of range in space and time. I just wanted to ask, in your backwards trajectories studies that I guess you're planning still to do or to finish, what are the major sources of statistical or systematic uncertainty that you're considering, and do you have any plan to quantify them?
Regarding the data or the method or yeah. Okay, the uncertainty can come from various sources. One example is that so here we are having long-term study, so we are collecting data from different sources. So this also can induce some uncertainty. because the people are using different instruments, and so we have to consider this data, but we need to acknowledge that there might be some uncertainty in this data set. But also the tools that we are having, they are also associated with some uncertainties. For example, PMF, this is the main one that I'm using for source apportionment. So the major problem with PMF is that it's difficult to distinguish sources which are having similar chemical fingerprints. So this can also lead to some uncertainties.
I think I can also complete the statement of Elie by telling that the more data, the more robust is the statistics, and there is a lot of data per sector, for instance, for trend analysis. So that's also another way to reduce the uncertainties, is to have more data, to reduce the uncertainty linked to the quantity of data, to have more robust statistics, I would say. But it's a combination of everything, I believe. It will be, but if you have inputs, if you have ideas how to quantify, let's say, uncertainties, it will be great.
There's a statistical uncertainty, as you said, it's probably you need to gather more data, but it's also the systematic component that it has to do with the tools and then that it cannot be reduced by just doing more and more experiments. For example, when you do the backwards trajectory with NCAR data, you could also try to do it with another reanalysis just to quantify how much it comes from the reanalysis data itself. There's different ways to quantify the statistical uncertainties. And it'd be nice when you present your results to also give a sort of range, a statistical or a combined or range of uncertainty. I think that would be a good thing. Also, when you, because I understand you're now going to be going to the final phase of completing your PhD, I think it'd be nice to discuss these uncertainties as part of your analysis.
Yeah.
Thank you.
Thank you so much.
Other questions? Behind me? I cannot see. No? Unfortunately, I cannot see any. I mean, I have the link of the committee and don't have the link of the other participants, so I cannot see anything in the chat. I don't know if you have access in question in the chat. This was not given to me.
There's no question here.
There is no question in the chat. Then it's okay. Then we are closing now this public part of the examination. I would like to thank everybody for being attending. A lot of people in the room makes me very happy. Makes us very happy.
Me too.
Thank you also, Elie.